Welcome to solverfy.
We are asked to use generating functions to find a number of ways to make change for $1. And in part A, we are asked to do this using dimes and quarters. So the generating function for dimes, since these are 10 cents, we have that the generating function contains all powers of x divisible by 10. So this is 1 plus x to the 10th plus x to the 20th, and so on. We have that for quarters, this contains in its generating function all powers of x which are divisible by 25, so 1 plus x to the 25th plus x to the 50th, and so on. And so we have that the total generating function is the product of these two generating functions, 1 plus x to the 10th plus x to the 20th, and so on, times 1 plus x to the 25th plus x to the 50th, and so on. And in order to find the number of ways to make change for $1, this is the same as the number of ways to make change for 100 cents. And so we want to find the coefficient in this generating function of x to the 100th. To do this, notice that 100 divided by 10 is 10, and so we only need to include up to x to 100 in both. So we have 10 terms in the first sum. So 1 plus x to the 10th plus x to the 20th up to x to the 100th times 1 plus x to the 25th plus x to the 50th plus up to x to the 100th again. It's 25 divides 100. And using a computer algebra system, we can expand this and find the coefficient of x to the 100. We find that this is going to be 3. So 3 is our answer for part A. In part B, we're asked to make change using nickels, dimes, and quarters. So now we have the same generating functions for dimes and quarters, but for nickels, this is going to include all powers of x divisible by 5. So this is 1 plus x to the 5th plus x to the 10th, and so on. And so we have the total generating function is now going to be the product of all three generating functions, 1 plus x to the 5th plus x to the 10th, and so on, times 1 plus x to the 10th plus x to the 20th, and so on, times 1 plus x to the 25th plus x to the 50th, and so on. And we want to find the ways to make change for $1, which is 100 cents. And so we only want to include terms up to degree 100 in each product. So we want to find the coefficient of x to the 100. Well, can abbreviate each of these products to 1 plus x to the 5th plus x to the 10th plus, and so on, up to x to the 100, since 100 is divisible by 5, times 1 plus x to the 10th plus x to the 20th up to x to the 100, since 100 is divisible by 10, and times 1 plus x to the 25th plus x to the 50th plus x to the 75th plus x to the 100th. And using the computer algebra system, we can expand this polynomial and find the coefficient of x to the 100th. And if we do so, we obtain that the coefficient of x to the 100th is 29. In part C, we're asked to find change for a dollar using pennies, dimes, and quarters. So we have the generating functions for dimes and quarters, but for pennies, this is going to include all powers of x, which are multiples of 1. This is going to be all integer powers of x, so 1 plus x squared, and so on. And the total generating function is going to be the generating function for the pennies, 1 plus x squared, and so on, times the generating function for the dimes, which is 1 plus x to the 10th plus x to the 20th, and so on, times the generating function for the quarters, which is 1 plus x to the 25th plus x to the 50th, and so on. And we're looking for the number of ways to make change for a dollar, which is 100 cents. And to do this, we want to find, in the expansion of this product, the coefficient of x to the 100. And to do this, notice that we can abbreviate each of these sums to the 100th degree term. So we can write this as 1 plus x squared up to x to the 100 times 1 plus x to the 10th plus x to the 20th up to x to the 100 times 1 plus x to the 25th plus x to the 50th plus x to the 75th plus x to the 100. And using the computer algebra system, we can expand this polynomial and find the coefficient of x to the 100. And after we do so, we find that this coefficient is going to be 26. And finally, in part D, we are asked to make change for a dollar using pennies, nickels, dimes, and quarters. So we have the generating functions for all of these, and we have that total generating function is going to be the product of all these generating functions. So for pennies, we have 1 plus x squared, and so on. For nickels, we have 1 plus x to the 5th plus x to the 10th, and so on. For dimes, we have 1 plus x to the 10th plus x to the 20th, and so on. And for quarters, we have 1 plus x to the 25th plus x to the 50th, and so on. And because we're looking for how to make change for $1, which is 100 cents, we want to find the coefficient of x to the 100 in the expansion of this function. And to do this, notice that we only need to include in each of these terms, some terms, the power of x up to 100. So we can abbreviate this as 1 plus x squared up to x to the 100 times 1 plus x to the 5th plus x to the 10th up to x to the 100 times 1 plus x to the 10th plus x to the 20th up to 100, and finally 1 plus x to the 25th plus x to the 50th plus x to the 75th plus x to the 100. And we can use the computer algebra system to expand this polynomial and find the coefficient of x to the 100. And if we do so, we find that the coefficient of x to the 100 is 242.